So this is Computer Science 305, Programming Languages, and today we'll be talking about, this is the first lecture on Ruby, the Ruby programming language. And so we'll be kind of walking through a few different things, but it will consist of a significant number of examples and might be extraordinarily long. But you should be pretty good to go with a large portion of Ruby. And then the following lectures will go into more depth on all these different concepts. So first off, Ruby is an interpreted language. It's also a hybrid, as we've talked about in class, and the things that we're going to focus on specifically is the fact that we can use Ruby as an imperative language. And so Ruby can be executed in two different ways. We'll focus on the first one, which is through the interactive Ruby shell. It's called IRB, so you need to open up your command prompt. And at the command prompt, you can type in, assuming that you've installed Ruby. And we can verify that, of course, by saying Ruby-V, and see we have 2.5. And so we know that we have the command IRB. Now, I'm assuming that you have the capability to execute this because your path variables are set correctly. If they're not, I would suggest looking into that. But anyway, we'll begin. So we run IRB, and what this does is it gives us a prompt, which we can then type in any Ruby statements, and it will execute them. And so, for example, the most base level thing that we can ever do is, of course, printing hello world. Now there are three different ways we can print anything to the screen, and I'm going to use all three really quickly. So the first one is we can just type in print, right? Or actually there's like four ways I can think of now that as I think about it. But let's say we can type print, and we say hello world, exclamation point, and then print does not have an extra line, does not end the line, so we have to put an end line in there, and that prints hello world. If we want, we can also type P, hello world, and then P is a shortcut for puts, and lo and behold, it prints out hello world, and P also returns the string hello world, right? Whatever it printed out. Whereas we saw before with print, it returned nil. So just bear that in mind. We can also type puts and then hello world, which just like print returns nil, and then we can say printf like we could in Java. Also note that I'm not using parentheses, although these are all method calls, so you can use parentheses if you wish. For the most part in Ruby, we don't need to actually have parentheses unless it would be a confusing statement for the Ruby interpreter. And so we can use printf as well. So these are the four main ways, and I'll kind of interchange between them as I go along through these lectures. So moving forward, typically variables and expressions are pretty easy concepts. Variables are not, there is no strong type, no, let me rephrase that. There is no static typing in Ruby, right? It's a dynamically typed language, so our variables can have any type any given time. So essentially, and to create a variable, I just give it a name. So for example, a, and I can assign using the equals operator, just like in Java, and say a equals 10. Note that these lines are not required to be ended by anything like a semicolon, although that is perfectly acceptable. I can say a equals 10 semicolon, and it considers line and returns 10, the value of the last statement executed. And so I can say then b equals 3 times a plus 2, and that gives me 32, right? As we should expect. Now I can go and try printf, right? And we can say %d %d/n, and then we put in a and b, and that would give us should print out the two values, 10 and 32, and that's what we see. We can go ahead and do this again without parentheses, as I already mentioned before, and it will also work. So we can also adjust b, and we can now say b is equal to the string a string, and then we can have a new variable c equal to another string. So in Ruby, just like in, for example, Python, strings can be either delimited with double quote or single quote. Doesn't matter. And interesting enough, then within those you can use the other quote without having to escape it. So then we can say print B plus and plus C plus new line, and I need to end that, would give me a string and another string, right? Alright, so that's your basic expression concepts. We can also do a few more things. Let's say, just like in any other language, we have the same capabilities to, let's say we have x equals 4, we can do relational conditions. So if we say x is less than 5, that comes out to be true. If we say x is less than or equal to 4, that's also true. But if we say x is greater than 4, that comes out to be false. So our Boolean literals are true and false, right? But they're also objects. So they have different methods and they have a class associated with them. So if I say true.class, that gives me true class. And same with false.class, we get false class. Furthermore, numbers as well as strings are also methods. Also objects, and so for.class is integer. If I say for.methods, I get to see that it has all sorts of things, including all the operators and operations that we'd expect, like, for example, plus and minus and divide are all operations that are also methods. So if I want to say 4 plus 4, right, which is 8, I can also say 4 dot plus in parentheses 4, and that's the exact same thing. So Ruby gives us this really nice shorthand for writing all these things out. We also have the capability to do for triple equals, and then I can say x, right? That comes out as true, and this is a type of equals where we're actually saying that it is pointing to the same object in memory, whereas double equals tests for value equality only. So in the case x, both x points to 4, and I can also say, for example, if I have y equals 4, I think x should be triple equal to y, right? But you know, we're not going to get into that too deep into detail. There's also another operator that you should be aware of, and we'll talk about this at the next major Ruby lecture, but is the greater than equal to less than, the less than equal to or greater than. So in this case, it returns a -1 if the value, in this case, if x is less than 4. It returns 0 if x is equal to 4, or returns 1 if x is greater than 4. In this case, x is equal to 4, so it should return 0, which it does. Okay, moving along. Now we have x is equal to 4, right? So we can also do a lot of decision work, your typical if-then-else type experience. So if I have a string, let's say this appears to be false. And then what we want to do is, if we want to do this, if we want to only print this if a statement is false, then I can say I'll print this string unless x is equal to 4, right? And so it didn't print that, right? Because x is equal to 4. Now I can do the same thing, except for then I can say if, and I'll actually say true. So we print that if this appears to be true if x is equal to 4, and it appears to be true because x is equal to 4, so we see that printed out. Now these are equivalent to saying, for example, x is equal to 4, and then if I say if x is equal to 4, and then I say p, this appears to be true, and then for any time we have an if statement, or when we end the if statement or an unless statement or just anything with the end keyword. So that's how we end the block statement. And so then of course it does exactly what we want to. It printed this appears to be true. We can also say unless x is equal to 4, and we say p, this appears to be false, and then we say else, right? And we say p, this appears to be true. All right, and we can end that. And then of course it prints this appears to be true because x is in fact equal to 4. So if we can do one more where we can say if x is equal to 3, then we will print x is 3, and then we can say else. So if we want to do else if, we say else if p is let's say we'll print x is not. We say, oh, sorry, I have to actually do this as a statement. Our else if condition will be, let's say x is greater than, we'll say greater than or equal to 4. Then we print p x is greater than or equal to 4. And else we print other. And we call that good. And right, so it did print x is greater than or equal to 4 as expected, right? So else if takes a condition just like if and an unless, and so it gives us that capability. Now we can also simply we have all different kinds of different possibilities for our Boolean equations, but we can also say puts this appears to be true, and we can say if not true, right? And this is equivalent, as I'll show, because I didn't print, right? Obviously, it won't print because not true can never be true. We can also write that out as we would expect from Java with the exclamation point. So it's a little more Ruby-esque to use the actual word not. And I think it looks cleaner, but that's my opinion. Furthermore, we can also use, just like we did before when we were doing the printing with the conditional unless or ifs at the end, we can also do something similar with while. So we can say, let's say we have an assignment x is equal to x plus 1, and then we can say while x is less than 10, and so this will execute until x is equal to 10. And then we can take a look, what is x? Well, x of course is 10, right? Now we can do a very similar thing. We can say x equals x minus 1, and now we can say until some condition is met, where we want to say x is equal to 1. And then, now we can look at x again, and we see that it is 1. All right, these are equivalent, right? We can write the until and the while statement just like we did with an if. We can say while x is less than 10, x equals x plus 1, and we'll just print out x, and we say end, and that prints from, because x started at 1, prints 2 through 10. We know that x is 10, and then we can do the same thing. We can say until x is equal to 1. We can say x equals x minus 1, and then we print x. We say end, and lo and behold, it gives us 9 through 1 as we expected. Alright, so that's the pretty easy day stuff to do. Very quick intro to Ruby. We'll continue on. In Ruby, so what we'll do is we're going to shift now from writing code inside of the Ruby interpreter, and we're going to shift to and you can escape the Ruby interpreter by I use Control D there. If I run it again, you can type I believe exit or quit. All those will get you out of the interpreter. To run a Ruby program, let's say we want to make a really quick one, right? So I will use VI for this, and we'll call it ex1.rb. So Ruby files all end with a .rb extension, and so now we're inside this. One of the things I did want to note was sometimes you have to create these types of variables that are called global variables, and so global variables start with a $sign. You don't have to do this for all of them, but if you want to access these variables inside of, say, object or a class or a module that you make, which we're not going to go into any of these things, but just for future reference, you can. So we'll say greeting is hello, right? It's our global variable. Also note that comments in Ruby for single line comments start with a hash mark. And then we can say puts, and now inside, so before we used, for example, dollar greeting, and then we can say plus, and we can give a name like, say, Prudence, right? And this will work. Another way we can do this is to also, instead of having to use string concatenation the way we did, we can use another thing called string interpolation, which requires us to use the double quote string. And what we can do inside of the string is we put a hash mark followed by curly braces, and anything inside the curly braces will be executed as a Ruby statement, and the value returning from that statement will be converted to a string and then displayed. So in this case, we can put $greeting and then Prudence, and we'll get the same thing. Actually, let's make that different. Let's say Isaac, and we save that, and we run it. Now we can run a Ruby file at the command line by calling Ruby. We say Ruby and then ex1.rb, and we run it, and lo and behold, we see the output that we expected. So I'm going to shift now to an actual editor. For editing all my files, I use right now for Ruby at least. I've used many different IDEs and other tools, but for the purpose of this class, I'll be using what's called Atom. Atom is a editor made by GitHub. In my opinion, it's probably one of the better ones. You can also use Sublime Text. It's very good. I've used a whole bunch of different ones. For the stuff that we're doing, I would refrain from using any one IDE. I do know that Atom provides plugins for all the languages that we're working with, so that there's syntax highlighting for all of them. I'm pretty sure Sublime Text does as well. You'd be hard-pressed to find editors IDEs that easily do all this, although for Ruby and Java, I do know that the JetBrains company makes pretty good editors for both of those languages. So, shifting away to this, we now see that this was the example we were just editing. The reason I like Atom is because I also have the ability to have a terminal in there. Not that you can't have that in other languages, just happens to be that I like it to have it in this one. We will be running a few different things. The next thing we're going to look at is, what is the value of truth? What makes things true in Ruby? And so we'll create a new file really quick. We'll call it ex2rb. And so let's think about this, right? So let's go back to our this appears to be true stuff. Right, so if I say this appears to be true, and then now if I want conditional, if I say if 1, we would expect that if we were thinking like in C, but not in Java, that in C, if I did a conditional expression just evaluating 1, that evaluates to be true. And so if I say Ruby ex2.rb, we see that that is also true here, right? 1 appears to be a truth value. If I do the same thing, but instead this time I just choose random string, well, we might think, well, that might not work out quite as well, but in fact it does, right? It gives us a warning that we use a string literal in a condition, but the interesting thing here is that we will find that pretty much anything that's an actual valid object turns out to be true. And that means that if I put in if 0, which if we were recall from when we program in C, if we do a conditional expression with 0, that will evaluate to be false. But in Ruby, that is not the case. The only thing that evaluates to false, right, and then of course true also evaluates to true, but the only things that we'll find that evaluate to false are themselves false and the value nil. Which would correspond to null in Java. So, this is just something to be aware of inside of Ruby. Now, if we go and execute this one more time, we can see, just be sure that the first 4 items do evaluate to be true, right? Actually, and then the last 2, they don't print anything out, right? Because they evaluated false. So, we want to verify that that was, in fact, correct. Now, I will run the IRB here in Atom just because there's a few things I wanted to show when we were talking about Boolean logic. So IRB, let's say we have, let's see if I can bring this up a little bit so it's a little easier to see, and we say Control L. All right, so we're in here, right? Now, if we use the AND operator, which is just like the double ampersand, if we say true and false, right, we expect this to come out to be false. If we say true and then or, true or false, we expect that to be true. We say false, double ampersand false, we expect that to be false. If we say true, double ampersand, this will cause an error. This will cause an error is some unknown variable. We expect that to throw an exception because, well, it doesn't know what that is. So, but if we were to execute false and this will cause an error, we see, oh, hello, not false E. If we run that, we should see just false, right? Because it uses short circuit logic. It will handle it as soon as it sees a false in an AND condition, it automatically evaluates the false. If it sees a true in an OR condition, it automatically evaluates the true. And we can see that again. If we try true or that thing, we get true, right? Same if we use the double bar. Now, in Ruby, you can also use a single bar. Now, what this does is this says we're not going to use short circuit logic, mainly because we might have some function call or something that has to be evaluated as a part of this condition, so a side effect. And so we want the whole thing to be evaluated. Well, when we do that, we get the error again. And we can also do the same thing if we did false and a single ampersand. It will cause the error as well. So, just to be aware of all this. Now if we go back to writing code in the editor, I'll clear this out and so we can actually see what's going on. We can start moving on to a little bit more information about strings. So as we already talked about, strings can be identified using single or double quotes. And we can also do string interpolation with the hash and the curly braces around a statement inside Ruby. So as I said before, let's say we say PA equals, and then the hash, and then we put an A, right? We'd expect to see the value 17 printed out. So we run this as Ruby ex3 to RB, and we see that happens. Okay, everything looks great. Except for if we do P single quote A and then the hash mark A. If we do that, as I said before, it will not evaluate it. It will show us literally what we typed in. And so that's why we have to use double quotes. Now, sometimes if we're extremely verbose people, and I know I am, we can use a extra long string or a multi-line string by using a triple quote. So this is a longer string, perhaps some instructions or agreement. I can't spell agreement. Goes here. By the way, A equals A, right? And so we can still do interpolation, and that's because we used a double quote, right? So if we go ahead and print B, we will see all this worked out. Actually, we'll put puts because it makes it a little more pretty to look at. We'll run it again, and lo and behold, actually, puts did not give me the prettiest view of that. But anyway, so we see that it converted it to the string, and A equals 17 as expected. If we did the same thing with a single line, it would kind of a single quote for triple quotes. It would give us a completely different thing. Now. There are a couple other ways to do that. I'm not going to dwell on it too much. I'm not too concerned about that. There are some other things that we can do with strings. For example, if we say S equals, hi there, how are you? And then we want to print that, right? So we say, let's say puts s.length. So if we want to find the length of the string, we just call the length method on it. And then we can also print s, right? So let's go ahead and do that, see what happens. And we see it's 22. That's the length of the string, hi there, how are you? We can do some other things, like if we need to access an individual item inside the string, we can say puts, and then if we just want, actually we'll do print. If we want the fourth, the character at the fourth index of string s, we can say 4 in brackets as if we were accessing an array, /n. We want to, and we look at that, and we see it's h, right? The fourth index, which is the h in there. All right. Similarly, we can use printf to do the same thing, and we say %c/n. We say s4, and lo and behold, we get the same thing. Now, we can also substring, and so we substring items by, in the brackets, we put some n, some l, where n is the start position, so the start index, and l is the length of the substring, right? So if we do that, we can say puts s, and let's say 4 by 4. Maybe we want to make this a, let's interpolate this. And we'll put square brackets around all of it. Sure, that sounds good. And then, furthermore, we can also use a range, right? So range, which is some n to some m, which is inclusive, right? So that extracts characters starting extracts a string starting at index n up to index m inclusive. If you did a range n triple dot m, it's the same thing. Extracts a string starting at index n up to but not including m. So for example, if we want to do this we'll do 3 of these, right? And we say this would be s, and we'll say, I don't know, let's try 6 through 15, and we'll do the same thing again, except for it'll be triple dot. This would be s 6 15, just to validate. And we end that string. Hello. Okay, very good. Let me run that. And as we see, we have... oh, my bad. But anyway, so it says the first 4 characters, the 4 characters starting at index 4 was here. And then starting from index 6, which is it gives us up through 15, which would be this. And then, of course, up into but not including 15 would be 1 less than the previous one. So it looks good. All right. We can also we can also manipulate strings by saying, for example, if we want to, let's say we have the string wow, and we want to wow with a space. We want to maybe, I don't know, print that same thing out 3 different times. We can just call multiply it by 3, and we can see what that does. And it says wow, 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 and then it's good to go, right? So we can do all these different things. We can also access, or we can find out what is the index of. So we can say print s.index there, actually there with lowercase. We can also plus the space. We can index s. This is why you should always use interpolation. S.index, right? And that looks for the what is the index of the first occurrence of the string that is in parentheses there. We can say s.index of how, and I'll put that in string interpolation. See if I can do that. Okay. And we say string interpolation s.index of bogus, right? Which doesn't exist, and so it would return nil instead of a -1 or something like that from like Java. So if we did this, it goes ahead and it prints 3, 10, and nothing, right? So when nil is converted to a string, it converts to the empty string. So we just need to be aware of that. Finally, we can also reverse a string. We can just call the reverse method, and lo and behold, it reverses the string as we expect. Okay, so that's pretty much the basic concepts. Well, I think we got... Oh, there's a few other things that we can do with strings. Just so we can do this, it'll look hopefully interesting. There's a few other things you can do. You can, for example, and I'm not going to go too deep into this, but you can chomp a string. Chomp removes white space from the end of a string, the last character specifically. So let's say we print and we say, please enter a past tense. Let's just enter a noun. I don't want to get too deep into this. And then we say noun equals gets. Gets, just like puts things to the standard out. Gets takes in input from standard in. So then we say gets.chomp. So gets returns a string, right? So get string, just like puts is put string. So we say chomp. Chomp removes the last item from that incoming string. So in this case, it'll be the /n that we're trying to get rid of. So then if we print it, right, we say put noun, and we do that. Run this, and now it's waiting for me to type something in. So I can say Isaac, that's my name, and then it prints that out. All right. We can go a little bit further into some. Let's see. Oh yes, working with strings. So I'm going to just do this really quickly. So we have make a new file, and we're going to do a few interesting things, so we can actually work with some stuff, and it'll be an allusion to the upcoming lecture on. It'll be the upcoming lecture on regular expressions, and so we can start with this ex4.rb. So let's say we need to make a file, right? We'll make another file. We'll call it song data. And in here, I already have this created in a different file, so I'm going to go ahead and copy that all over. So song data is the name of some MP3, a time, the length of in minutes and seconds, the length of the song, the artist, and the name of the song, the title. All right, so now that we know that, we go back in here. Now what we want to do is we want to go ahead and read that data in and then manipulate the lines of data. And so one of the things we're going to do is first we need to create a file. So we say file.open. A lot of this stuff won't make any sense of why I'm doing or what I'm doing, but I'll try to talk about it, and then we'll actually see how this stuff works later on in a little more detail. So I say file.open, and I give the name songdata.text, and then we call it .each. The .each method is an iterator. Will iterate when it's a file, it iterates each line of the text. And so this gives us the capability to create a block, and so all blocks, for the most part, start with the word do, and then we have a variable. Now this is if we use the multi-line form. There's a secondary form of blocks that we'll talk about a little bit later today. So then I get the capability to have a variable, and this variable, in this case, represents a given line from the file, which is the reason I call it line. So whenever we create a block, we always need to end the block with the end keyword. So that's the pair. It's do end. And then what we're going to do is we're going to read in that line, and we're going to say line.chomp. All right, so we're going to chomp off the end of it, right? Because we don't want that new line character. But then we're going to split that string returned from chomp, and we're going to split on a regular expression. And this regular expression is going to, now I need to go back and take a look at this. We want to split on and get rid of all the white space, and so we're splitting on the white space, vertical bar white space, but the definition of the white space between surrounding the vertical bar changes for each one of these lines. So what we want to do is we want to be able to deal with that correctly. And so initially, in order to do that, we use /s. That means white space. Star means 0 more spaces in this case. A vertical bar. So vertical bars are special characters inside of regular expressions, so we need to escape it. So vertical bar, and then the same thing. Space, star, and then we end. So pattern. So regular expression pattern is it's a literal is defined by using by a pattern specified between two forward slashes. And so this gives us the capability to now perform that split correctly. Now we need to assign So if we go back and look at our song data, what that will do is break it into 4 different pieces of information. The name of the file, the time, the artist, and the title of the song. So we can actually, in parallel, assign all those at the same time by saying file, length, name, and title. And so then we can actually use this. So let's say we just want to print some of that information out, right? So file, and then we'll give it the file, and maybe we want to say what is the length in parentheses, right? And then we'll print out the next line, maybe move it over by artist, and then name, and then we'll do one more line, which is the title of the song. And then we'll give it a space between each one. So we do that, and we run this. We should be able to see puts Ruby ex4 RB, and we see that we get everything we want except for the extra new line. But anyway, I'm not too worried about that right now. So it gave us everything we wanted to see, so that's all good and everything. Now maybe what we want to do is we want to notice that there is this extra long space here between these. So I'm going to change this up. So maybe what we want to do is we don't want to see like maybe the file information. So let's change this up to be instead just a single line, song, and then title, double dash, the name, the artist, space, and then in parentheses the length of the file. All right, that should be good. We run that again just to be sure. It gives us those 3 things, but then we start seeing that extra spacing that we were using to make everything look all pretty in the file, right? Makes it look pretty. We don't want that. So we got rid of the stuff after the name, right? Before that, after the name of the file, before the vertical bar, but we're not getting rid of the stuff in between artist names. And so let's go ahead and fix that. So we can do that really easily. Because we're only dealing with name, we can say name.squeeze, right? And so the squeeze function, what it does is it takes repeating characters, whatever character we give it, which in this case is the space, and what it's going to do is squeeze those down to a single character. And so, furthermore, we use the exclamation point. There's 2 different versions of this. There's one with an exclamation point and one without. The one with the exclamation point says, we're going to apply this to the actual object that we are calling this on, as opposed to applying it and returning the modified version as a new object. And so now that we've done that, we run it, and we can actually see what happened. And lo and behold, it has squeezed that down, so now we don't have that ugly looking extra space in there. So one final modification we can make is perhaps we want to go ahead and only display the length of this in seconds rather than in minutes : seconds. But if we think about this, length comes in as a string, right? So if we were to, before we do this, we'll print out length.class, right, just so we can verify. Go ahead and run this, and we can, length doesn't exist there, so let's go ahead and do that up here. And so we see length.class is a string, right? So we don't want to deal with that. We need a number. So the first thing we want to do is we need to extract the minutes and the seconds out. And so we can do that by saying length.scan. And this takes in another regular expression, or a string actually, if we really want to. And we're going to use a regular expression. And the reason we're going to do that is because we can use the class D, the /D, which looks for any digit. And we can look for one or more of those. And so every time we find one of those, and we know there's going to be only 2, we can then assign those to, the first one is the number of minutes, and the second one is the number of seconds. And now we have the capability to extract it out. We could easily have split it on. So another way we could have done this, and I'll show that really quick, is to say length.split. We can just say look for this string. We're going to split on the colon, right? And that will return also. So we say min sex, and then but that's going to return 2 strings. So that's not going to really help us. We want actual digits, right? And regardless, it's not going to help us either way. So let's just try it this way first. We'll come back to the irregular expression one. And instead of using length here, what we'll say is mins.2i, 2 underscore I, which converts it to an integer, multiply it by 60, and then add that to sex.2i. And then we can verify this worked correctly by running it. And unfortunately, I get a undefined local variable, which, oh, so that does give us a problem. So, so min is so length dot split actually returns an array. So that's not going to do everything we want to. There is a way to do it, which would be to say, to do this by saying, this is our nums, and then what we can do is say min equals nums 0, and sex equals nums 1, right? And that should work. Or it keeps giving me a failure. So I'm just, and I'm looking for mins. Okay, that's the reason. All right. And that works as well. I'm pretty sure I could have done it the other way as well. So I'm going to get rid of all that and use this the scan method. I like that. It's a little more cleaner looking in my opinion. We use this regular expression. So the slash d looks for any digit 0 through 9. The plus says 1 or more times. And we do that to give min and sex as we want. And lo and behold, we get the same value again. All right. So that's how we deal with that type of stuff. Now we can move on to understanding a little bit more about numbers in Ruby. And this gives us some interesting approaches to handling stuff as well. So let's call this ex5.rb. And so here we are dealing with numbers. So let's say we have variable num equals 81. Okay. So now numbers, right? Number values, constants are also objects. And so they have all sorts of different methods. So we can say IRB and Control L. And so we can say 6 dot times, 6 dot methods. They give us the methods that are available to us to call. And then you can also go look this up inside of the Ruby API, which is one of the things I'm going to have you guys do as part of your furthering learning before coming to class. But there should be a method called times somewhere in there. But anyway, yes, times right here. And then also there's this method down to times. There's even, odd. These are 2f for float. The GCD, LCM, all these really great math things that we can do. So, you know, real, imaginary, all these great things. So, the integer class has lots of different things that we can do. And so one of the things that we're going to use right now, we're going to use a couple of these. So we can use numbers to control iteration. Think about it like this. Oftentimes you want to do like, I don't know, a for loop. Well, in Ruby we have a for loop, but it's almost always not necessary to use. So, for example, let's think about this. 6 dot times. We give it a block, right? We could give it a variable, but in this case, we're not going to use one. So we say puts and interpolate num.class, right? Num's the 81 above, and we say, and then sharp, we'll say num. And then what we're going to do is we'll then multiply num by itself times the equals, just like we can in almost every other language. We can use compound assignment. Say num, and then we end the block, and we'll go ahead and run that. And we see, oh, hello, that'd be 5. And we get, we start at 81, and we just make this giant, huge number. Also, this is an extremely large number. I think it's probably beyond the capability that even Java would be able to show. We probably would have overflowed. I'm not going to get into whether or not what the maximum size of an integer is. I don't really care. Just the fact that we could actually do this 6 times as expected is the only thing that I was really concerned about. We can also use a block, as I alluded to earlier, a different form of the block. Instead of using do and end, we could do it a different way. We can say 3 dot times, and in curly braces, we can then put the thing that we care about. So this would be like, for example, print the letter X, right? And then maybe we want to use a different operation, 1 dot up to 5. And then in here we're going to use a variable I in vertical bars, and then we want to say print I, and then a space. And then let's say we want to do from 99, and then now we can instead of using the dot, so almost all methods in Ruby can don't have to have a dot following them, so we can use down to 95, and then we can say I again, print I, and then the space. So let's go ahead and run this just to validate that what I'm saying is actually going to work. And then we get a problem. Okay, yes, very good. I was wrong. My bad. Let's just do that. Make it easy. Run this. And so what we should see is right now we have 3 X's, 1, 2, 3, 4, 5, 99 through 95, separated by spaces. So let's go ahead and finish this off with one last one. We can step. So down to starts from some number and goes down to a given one. Up to starts from some number and the number is called on, up until the number of its argument. Step starts from the number it's called on, and then goes to the first argument, up to the first argument by the second argument. So in this case, it'd be stepping up from 50 to 80 by 5. So this should show us 55, 60, 65, and so on until we reach 80. So we print I, followed by a space. And then, of course, we want to print the new line, right? Just puts, all right, just so we have that. Go ahead and run it. And lo and behold, we get what we expected to see. So this is some basics on iteration and as well as using numbers. And I implore you to explore the rest of those things. But for the rest of this, we're going to move on to some arrays and some other basic data types like hashes. And then we'll get into a little deeper on control, defining methods, working with blocks, gets, and ranges, and then I'll give you a slight taste of regular expressions, and then we will be done. Bear in mind that this is going to be like effectively an hour-and-a-half long lecture, so continuing, we're going to make a new file. We'll call this ex6.rb, and then this one we're going to be dealing with arrays. So arrays, our favorite things, right? Now Ruby, since it is dynamically typed, is pretty loose on what can be inside of an array. For example, an array can be composed of cat, numbers, strings, a floating point, pretty much just anything you want in there. This does have issues, though. If we want to do things like sorting on the array, they kind of need to be comparable items, and a string and a number are not comparable items. So just bear that in mind when you go ahead and do this. So if you want to print out A, right, we print out A0, right? We index it just like in Java or C. We use zero-based indexes. So if we run this, we should see the first thing that prints out will be 1, right? Oh, hello, I need to save. So we go ahead and run that one more time, and we see that we get 1 as expected. All right. So now if we want to do assignment to the array, we can just put it in the item that we want to assign to, in parentheses, the index, and we put whatever the value is. So we do that, and then we print out A again, the entirety of A, and we should see 1 cat nil. All right, we just changed 2 to be nil. All right. So moving a little down the road here, let's say we want to make an array of strings. Be cat, dog, and elk. All right, good times. We want to look at, just to further enforce this, we'll print out the first 3. We'll print out a couple of these things just to see what we got here. And so we do that, and we run it, and we get ant and dog. Looks great. But that was kind of annoying to have to do this, so there's another way to deal with this. We want to make an array of strings. We can say A equals, and we say %W, and then in curly braces, we type in the things that we care about separated by spaces. And let's just print A just to see what it looks like. And we do that, and we see it's an array of strings, the exact same thing that we put in the first one. So moving forward, we can then create a new array. This one will be of numbers, 45, 3, 19, and 8. We then create a second one. We'll call it B, and in there we'll put Sam, Max, 56, 98.9, 310, and Jill. So now there are a couple other things we can do. For example, if we want to combine two arrays together, we can use the and then turn them into a string. Basically, we can say P, and we want to join A and B, A plus B, right? That will the A plus B will combine the two arrays together into one. And then if we want to turn this into a string, we can use the join operator, and then give it whatever we want to separate the different values out with. All right, so we do that, and what we should see is the two arrays printed out as a single string with spaces in between, and that's exactly what we get. So that worked out pretty well. Now we can also index the arrays with negative numbers. So unlike in Java or C, we can use a negative number, which is very similar to Python actually. And if we want to, we can, let's say we want the second index of A, we want the fourth index of B, and maybe the 2 from the end index on B as well. So we can do that by saying B -2, right? So -1 would be Jill, right, the end index, and 10 would be the -2 index, right? So when we use negative numbers, we index starting at the end and moving backwards. When we start with 0, we start from the front and move forward. Anyway, so if we do this, we should see 19, 4 would be 3, and 10. And that's what we get. So that worked out pretty well. Now we can also go ahead and sort things. So let's go ahead and call a.sort, and then we'll join that sorted array with the space again. So we do that, and we get exactly what we want, a sort array. Now, as I said before, if we try to run sort on one that has uncomparable items like strings and numbers, it will give us issues. So if we call b.sort.join, it will give us an error. As expected, we can't sort comparison of string with 56, right? It was trying to do the comparison, so the first things it saw was Sam and Max, so it had the ability to do the comparison on those two items, and so it was trying to sort them, but then it hit a number and it didn't know how to sort that. So that was a failure. So we'll get rid of that. Another way we can actually build up a list or an array is with the shift operator. So we can take A and we can shift into it 57, and then 9, and then fill. And if we print A dot join with a space, we should see 9 and fill got added to it. Now the interesting thing is, note that when we called sort up above, right, it sorted the array and then joined it, but it actually what it was doing is it sorted A and then returned a new array. So you can, I believe, sort. So if we actually what we'll do is we'll do that in a second here. If we what we'll do is we'll call a method called pop. So we say a.pop, and that will remove the last item. So fill is unsortable, and so if we say a.sort, and then with a with an exclamation point dot join, what we should see is we'll print that, and then we will also print A again just to see what happened. So we run that, and we see that we removed fill. That was what the pop did, and then we sorted the array, and then we printed the array again just to validate, and lo and behold, it is as we expected now changed. So we changed it. Now I'll add fill back in just so we can do some stuff. So a fill, and then we can do all sorts of things with this. Pop, as we just saw, pop removes the last item from the end of the array, and then we can shift, right, if we call shift, for example, a.shift, so we say p a.shift, that removes the front item. So we run this, a.shift removed 3, right? That's what we printed. And then we can also call, the other way we can delete things is by giving it an actual index. So we can say let's say a.delete fill, or sorry, we'll give it the, you can give it the actual value, or we can say a.delete, delete, we'll say 4, and we'll print both of these. So that actually returns, I believe, nothing. Yeah, so when we actually call the item, with the item, it returns the thing that we care about, that we're trying to delete. If we call delete with an index, it just removes the item. And so if we look at A right now, we say PA, we should see that it is missing a few items, specifically 3, and then I believe we're missing, oh, we removed fill. So did we actually remove anything? 0, 1, 2, 3, 4. Should have removed something, but oh, sorry. It didn't have 4. That was my bad. It's delete at. There we are. Now we run it. It should remove 57. All right, very good. Okay, that's the correct syntax. Delete at. Okay, very good. All right, now. So those are arrays. They're pretty easy to work with. There's a lot more operations you can do with them than what I'm showing here, of course. The next major data type is called a hash. We also know it as a map from Java, or a dictionary from Perl, and I think they call that data structure a dictionary in C#. So anyway, ex6.rb, oh sorry, 7.rb, and a hash is just a, oh, and they call it an associative array in various other languages. So hashes are awesome and easy to work with. Oh, I do want to go back to actually ex6 and talk about how we actually can create an array. So the last few things, so we saw that we can easily create an array by giving it items. We can shift things into it and manipulate it that way. But there's easier ways of doing this. You can create an empty array by saying, for example, a equals the empty array. A equals array.new with nothing inside of it. And then of course you can give it any value. So these are the main two ways of creating a new array. Similarly, if we want to create a hash, we can say a equals the empty curly braces. We can say a equals hash.new with nothing in it. And if we want to give it a default value for anything that we can't find, so if we give it a key that is unknown, we can say hash.new, and then we give it a default value, for example, 0. But anyway, we'll start with Z as our main thing we want to work with. When we actually know the values, we can start by using keys. And so there are two different ways we can do keys. Typically, we want to use a unique value, like a string. So, for example, Mike, and we say 75, and maybe Bill, and that's 18, and Alice. So what we see here is that we're creating, and we'll say her value is 32. So it's some key and some value, and they're separated by the rocket operator equals greater than. And then each one of these individual key value pairs is separated by commas. And so it's very similar to how we create an array. We can also create another one. We'll use the same values, but instead we'll use Mike. And so if we put a colon and then a word, that's called a it's called a symbol. And we'll say 75, and Bill is 18, and Alice is 32. So symbols are a special type of data structure inside of, or data type inside of inside Ruby. And so I'm going to run that really quick. IRB, and if I say Mike.class, says symbol, right? And the interesting thing about this is they cannot be changed. They're always the same regardless, and so they're always unique as well. And so a lot of things are symbols inside of Ruby. It's kind of an underlying data structure that holds everything, or data type that holds everything. But anyway, if we want to access, for example, value inside this, we can just give it as key. For example, Z Mike, right? So we print that out. If we run this, and we as Ruby ex7.rb, we see 75. Now, on the other hand, we say pz Joe, right? That will get doesn't exist, right? So it gives us nil. And if we went back up here and we want to adjust that, so we say, maybe we say Joe is equal to 44, and now we can assign that value. We can also do this for y, and we say Joe equals 44, and then if we want to print out let's say Z at Joe and also Y and the symbol Joe, we can see what we get, and we expect them to both be 44. So we see 44 and 44. All right, now we can also let's say we create. We can also test whether something has a key, right? So if we want to, we can say p does z dot ha. Oh, sorry, I need to put that z dot has key question mark. So if you're looking through the API documentation and you happen to see any methods that have a question mark, we already it's a Ruby convention that any type of Boolean method always or Boolean function always has the question mark at the end of its name. So that's just for clarification. Z dot has key Mike, and that should return true. So we'll go ahead and then maybe we'll add one more in there. Z dot has key, and we'll say Jones, right? Just to run that. And we see true and then false. A further mention is that I believe we can convert, for example, say Mike dot, or we can actually take the symbol. I'll run that. It'd be a little easier to do in IRB. So we can say Mike is a symbol, right? So we have Mike dot to_s. We'll convert it to a string representation that is Mike. And we can take Mike the string and say .to_sim, which converts it to the symbol Mike. So we can do all sorts of these things. We can also convert to an array. We can say Mike.to_a. We'll convert it to an array, and that failed because I don't believe there's a to-array conversion for that. Anyway, there's also a 2f, a 2c, a 2r, and this actually gave us all the different possibilities that we could use. Not everything has a 2a, but anyway, moving forward, Control D, clear. We can also go and I was alluding to the fact that we can use create a new hash for with a default value. So let's create a histogram hash, and then we'll give it a default value of 0. Okay, and so if we say p histogram key 1, right? Print it out. We have never put anything in this hash so it should give us 0, right? So then if we adjust this, we say p histogram key 1 equals histogram key 1 plus 1. We could also have used plus equals. We'll do that one as well. So what we'll see here is that it'll give us a 0, 1, and 2, as expected. All right. So that's pretty much the base gist on hashes for now. Next thing we want to look at is we'll talk a little bit more about control and a few things we can do there. I think we've talked a lot about how we can do if then else, so I'm not going to go too deep into that. We did while loops, so I'll move on a little bit further. Let's go to methods. So we can define methods, right? So far we have done pretty much nothing really important with Ruby. We've talked about all the basic low-level stuff that you can do, so let's actually define how we can actually create a method. And so we'll call this ex8.rb. And so creating a method is really easy. The basic syntax is we use the keyword def, and so we call them, some languages call these functions, some call it methods, some say methods can only be inside objects. In reality, when you write a script in Ruby, you're actually inside of a special class that is holding that script. We're not going to get too deep into that, but we can create a method by using def, and let's just say that Ruby calls all functions methods. So we can create this method. We'll call it say goodnight. So I don't know if you ever watched a really horrible show from back in the 90s called The Waltons. But anyway, at the very end of the show, everyone had to say goodnight because it's the bunch of people living in this house in the middle of the sticks during the Depression. But anyway, so the result of calling this is to say goodnight, and then whoever the name is, right? So everyone says good night to everyone else. Now we can explicitly return a result here. And so oh yes, the basic syntax: def, name of the method, arguments. Now the argument list can be in parentheses or not. It's not required. And then we say end. Okay. So then we can say we'll say say goodnight, and then John Boy was the main character, and then we could call another one say goodnight Mary Ellen, one of his sisters, and then at the very end they always said and good night grandma. Okay. Anyway, so we go ahead and we'll run this just to validate that this actually works, and then we're going to make a few modifications just to see that there are other ways of doing this. And as expected, it says good night John Boy, good night Mary Ellen, and good night grandma. Okay, so it looks great. Now, interesting enough with Ruby, the last statement that executes inside of a method, if there's no explicit return, is the return value. So we can remove all that extra business, and we'll just have it create this string, and that string being the last line of the method will be the return value. So if we go ahead and run this, we see the exact same thing. Alright, so excellent. We did a lot of good work there. Now we can make a few more modifications, right? Just to make this more Ruby-esque, if you will, by using string interpolation. And we'll add in one more, so we say puts say good night, and then we'll do it just to validate that we can do it this way, and we'll make it a single. Yeah. All right. So we can do it all different ways, and we run this, and we say good night Paw gets added in there. So that's looking good. And so this is the pretty much the most Ruby-esque way you can write a function. So that being said, alright, functions are really useful, and then we can add in some extra capability to these things. Alright, so, or methods, whatever you want to call them, and this extra functionality that we can add in. So this would be functionality that's a part of the method, but defined outside of the method. It's kind of a trip the first time you do it, and it's called a block. And so we'll call this ex9 to RB, and so blocks are just like in Java. A block of code is created by defining it with curly braces. It's not the only way, but we can say puts hello. Alright, so that's a block. If we run this, it will run that block of code. Actually, it will give me a failure. That's interesting. Hello, 9, thank you. So let's I actually probably have to use that somewhere. So let's say do, and then we'll say puts hello and end. Hopefully that does not fail. It may. We'll find out. Also fails. Alright, good times. So, how about we say screw all that, and then here's what we do. Let's define a method. We'll call it call block, and we'll say puts start of method. This will make it a little easier. We already seen blocks being used when we did iteration each method earlier. We can execute these things, right? So let's say puts and then end of method, right? This is really simple way of understanding how this thing works. So blocks work. Note that there is no arguments to this method. We could even put empty parentheses on here, right? It's not required, but we can do it. So if we can call this, we say call block, right? Run this. Says start of method, end of method. Now we can add in some extra code. Maybe we want to say call block and we give it a block. Puts in the block, right? So if we did that, we expect to see something maybe change, but we still see the same. Now what we need to do is there's a special keyword that happens that allows us to actually execute any blocks that come in. And so we say yield, and what yield will do is it says yield to the incoming block. And so when we run this, we say call block, and then it says start of method, then we call yield, and then it says, oh, do whatever is in the block provided. So the block provided said puts in the block, so it prints in the block, and then we see end of method. All right, pretty easy thing, no big deal, right? Okay, we could also furthermore say yield again, and then maybe throw and try it one more time, and it runs it twice. Okay, so we see that's great. All right, we could also do this with a do end. I'll just do that one more time. So do, and then I probably should get rid of that end there, and then we say end. All right, looks good. Run that, same thing. So you can do that just the exact way we want to. So let's create another one. We can also have parameters to our block, right? So we can say def call block 2, and then we'll just yield here. And then inside the yield we'll say hello and 99. All right. And so when we call this, we'll say call block 2, and then we'll say do, and we have a string and a number that we care about, and then we'll say puts str, and then how much, and we'll say $, pound, num, right? End. So we do that, and we run this, and it gives us exactly what we want to see. It says hello, a hello cost apparently, or hello, how much? $99. All right. We could have done that easily with a single line block using the the curly brace syntax as well, and it works the same. So then that brings us back to understanding iterators, right? So anytime we have any type of a data type or construct, or even an object or a class that you define later in your life that has an each method, and each takes a block. So let's say we have some array with cat, dog, and horse. Apparently these are common animals that we care about. We say dot each, and then we say do and name, and then we can say print name, comma, space, and then end, and we'll do a puts empty line. All right, go ahead and run this, and literally it just prints out each item in there. So you can easily adjust this to do whatever you want. So we saw this when we were opened up a file and then looked at each line earlier. We can also do this with ranges as well as, and then we also saw, for example, we worked with 5.times, right? That takes in a block. It's a method that takes a block. That's all it is. We said print, let's say print star, right? And then let's say 3.up to 6, and we'll take in an I, and we'll print I, and then we can also do ranges, and we'll talk about ranges shortly here. We'll say A through E dot each care, and then print care, right? And then we'll puts to get the new line. If we run this, we should see 5 stars followed by 3, 4, 5, 6, followed by A through E. And that's exactly what we get. So, these are just ways of understanding how blocks and why we can use them. So, we can make our own methods that do the exact same thing. And that's kind of the Ruby-esque way of doing stuff. So, then I wanted to work with a few things. One more, just a few more examples, and then we'll be done. So, example, we'll call this 10.rb. And this is just simply working with the gets, right? So let's say we want to print triangle height, right? We want the height of a triangle. So we would say h is our height, and now we want so gets. And as before, I told you gets a string, right? String input from the user. Well, we want this to be turned into actual numbers, so we're going to say 2, and we want it to be a floating point, so f. So will give us the height of the triangle as a floating point. So maybe we can say print triangle width, right? And this we say w equals gets dot 2f, and then we'll claim that the area of a triangle is equal to 0.5 times the height times the width. All right. Now that we've done that, we can then print. I'll say puts triangle height pound h width pound w, and its area let's say colon has area and then area, right? So that should give us a pretty slick and easy deal to understand. So we say example 10, the height, let's say, I don't know, 5, and the width 10, so has a height of 5.0, width of 10.0, and has an area of 25, right? Because the height is half the height, 2.5 times the width, 10, 25. All right, simple math, simple thing to easily understand. Note that it is all floating point, right, as we expected. If we did this as an I, instead we get a possibly slightly different answer. So we say 5, 10. Now we would expect 25. What do we get? 25, right? Because Ruby will automatically change that for us. The 0.5 is a floating point number. That multiplication changed the whole thing. Okay, good times. So that was that. We'll do one more quick and easy gets here. I'll make this a new file just so we can say it. ex11.rb. Let's say we have a number equal to 1.23 and a greeting equal to hello. All right. So we say puts and string is our greeting, right? And then a number. And number is number. If I can spell that. Number. All right, good times. So now we can say, we can also do our printf, right? We'll printf that in one more way. So string, %s, number, and number. And we'll do this because we want to adjust things. It'll be 5. Maximum length is 5. Maximum floating point afterward, decimal place after the number of positions after the decimal place is 2. F for floating point /n. Greeting number. All right, that should be good. So then we want to get a line of string input. So we say line equals gets. We print the line, right? And then we say we can also say while line equals gets. And then this is the one thing that we haven't really looked at. We can actually check. Let's say we want to check if line is matches some regular expression. So the equals tilde operator is for matching, and then of course anything between forward slashes is a regular expression pattern. And so then we say print line, right? So if we match, so the matching operator returns true if the value, the pattern can be found in the string that we gave it. And then we say end and end. So we'll run this. So running this, let's take a look. This would be 11. Alright, so we printed out the number as expected 2 different times, just to see that we could do that. And now it's asking me for a line of text, right? So, hello, world, this is Ruby, right? Printed that out. Okay, so we saw how gets works in case we hadn't seen it already 3 or 4 times before in this example. And now we're also doing it again, right? This is the while loop, while line equals gets. And then we're checking whether or not we find Ruby, right? So we say, Python, Perl, and Ruby are scripting languages. Okay, yeah. All right. And then lo and behold, it found Ruby right in the middle there, and then it printed it back out. But if I say Java, C, C Sharp, and C++ are compiled slash semi-compiled and languages. Prints nothing. So, and then I had to kill it because it was an infinite loop. But anyway, we got us to the place that we need to be for the time being. So now we move on. One last thing before we hit we have 2 more examples that we want to walk through. One is on ranges, and another is on regular expressions. So we'll run the regular expression. We'll do the ranges first. So we'll call this ex12.rb. And so ranges are really cool, right? They give us the capability to succinctly develop a range of values. So first off, we'll run this in the IRB, right? And I'll bring that up. And so, first off, we want to look at what is, so a range like 1.10, right? That's a range, so we want to know what is the class of this range. So probably need to put that thing in parentheses so we can actually call that .class. So it's range. Okay, what are the methods available to us? And there's a whole bunch of different ones. We can, turn it into a hash. We can do all different things, right? So interestingly enough, we can do a lot of cool things with the range. With a range, we can also convert it to an array. So we say 1.10 and .2a, right? The 2a method converts it to an array of all the values from that range. If we were to do the triple dot, which is exclusive, right? We see that and it brings it to 9. Does not include 10. Furthermore, we can also do a few more things, like, for example, we can use variables in our range. So let's create an array. My array equals 1, 2, 3, right? So it's that array. We can say then 0, let's say p0 to my array dot length gives us 0 to 3, right? Creates that range. Okay. We can also use strings for our range, right? So we say bar bat to array, right? And it gives us bar baz bat, right? So it shifted that string until from the initial string to the final string, and it actually uses the minimum number of changes required to get there, which in this case was 3. So we can also, let's say we want to create a digit. So digits equals 0.9. We can ask questions like digits dot include, right? And then 5, right? Let's just do that. Does digits dot include 5? We said 0 to 9. It returns true. Okay. We can ask for the max. What is the maximum value? It's 9. The minimum value. All right, 0. And then we can we'll shift into back to the code, and we'll say let's create digits again. 0.9, and then we say digits dot reject. Let's say I where I is less than 5. So if we print this, right, it takes in, so dot reject takes in a block, right? And then it's going to use that block to restrict what's going on. So every single item in the range of digits will then be processed, and so what we'll do is we'll end up executing for based on that condition. So we're going to print that. So this is this 12? Oh yeah, it's 12. So run that, and we restricted anything less than 5, right? So we rejected all things not that did not meet that condition, and so we only printed out 5. We printed out the array 5 through 9. So convert that to an array for us, and printed out only the things that mattered. So we can also run an each on there, just like we did for digits. Oh, what's going on there? So then we can say print, or actually we can say digits.each digit, and we'll print the digit, right? Just simple concepts of what we're trying to do here. And then print out 0 through 9, as expected. Now, we can also use these things. Ranges can be used as intervals, right? So if we say p1.10, is this equivalent to 5? And we also let's run one more for that. And then we'll do those. So let's say, is it so 3.14159. So the triple equals is for value and type checking, right? And so we do this, and we should see that yes, 5 is in the range 1 through 10. 15 is not, but 3.14159 pi is. So we run that, and we get true, false, and true. All right. Similarly, we can use this on the string classes, and we'll do this for the same thing, but for z, and we should get true, false, and run it. Oh, sorry, did I not say that? Verify what's going on here. Wait, one. Oh, I didn't print those. That's why. Okay. Hello. Trying to figure out what I'm doing here. All right, there we go. And then we can see true and false. All right. So that's pretty much the gist of what's going on. Finally, I'll do a little bit of very basic stuff that has to do with regular expressions. It's the last thing. And then I'll let you guys go back to living your lives. So this is an hour and a half long experience. ex13.rb. So very basic regular expression stuff. Basic regex. Right? Regular expressions are just a way of doing pattern matching in strings, but these patterns can be very verbose, but also very powerful. And so regular expression by itself is its own type of language. It's deeply connected to regular grammars. I'll talk about more of that when you see the lecture on actual regular expressions, right? I'm not going to get too deep into how these things work or what they are. Just know that you can use them to conduct very powerful searches, as well as substitutions within languages. So, for example, let's say we print enter something mentioning a programming language, right? Okay. So we say line equals gets. All right. Now we say if line. And so again, like I said, the matching operator here, and we want to say we're looking for Perl or Python. So the vertical bar says, so the first part of this where it says Perl with a capital P will match exactly these characters, right? Now what I could do is I could put a little I at the end of this pattern here, and that will be case insensitive, so it'll match either capital P or little p Perl, and then so it's either it matches this one or it matches this. So it will scan the entire string looking to see if it finds either of these anywhere in the string, right? We have no boundaries on this at all. It could be at the beginning, it could be inside of a word, so it could look for pearls or pythons or X Python X, whatever you want, whatever, it'll find it though. And so now we're searching for that. And then if we do find it, we say puts scripting language mentioned, right? And then pound, and then the line. We can say in there, all right. And then we end. So if we run this, wrong one. This is 13. So it asks us to enter the programming language. So we'll go ahead and move that up and go Control L. Oh, hello. Control L. No, that's not go. But anyway, so we say, let's say we say Perl. Actually, we'll make it a little more difficult, challenging. Is this Perl? And we press enter. Tells us scripting language mentioned in is this Perl. So it found Perl. We'll run it one more time. We'll say is this Ruby? Finds nothing, so it doesn't print it. And we do it one more time. We say Python, and it finds it again, right? So works pretty well, does its job. So then we say, now let's do a little bit extra work, right? So in the for example, we can use this to our advantage by wanting to say we can print line.sub. Now sub says substitute, and then given a regular expression, it'll try to find that. Wherever it finds the first instance of that, it will replace it with the following string. So here we want Ruby, right? So if we do this, we should say, let's say we'll run that and we'll say Perl is the best. And in reality, what we meant was Ruby, but unfortunately we already typed it and I don't want to type it again. So we say that and then it returns, and then we modified it, say Ruby is the best. Now, if we were to print line again, we'll do the same thing one more time. We'll see that it did not actually change the original line. So if you run this, we say Perl is the best. And then we did the substitution, but then we take a look at it, we print it again, it still did not substitute. In order to do the substitution the way we want it, we need to actually use the exclamation point version, which says we're going to change the actual line itself. So we run this one more time, Perl is the best, run that, and then it changes it this time for good. So now, let's say we want to do the same thing, but instead, if we maybe we have multiple if we have multiple instances of for example, in this case Python, and we want to replace them with Ruby, but we won't replace every single one. We have to use gsub, which stands for global substitution. So we'll go across the entire string and substitute Ruby for every instance of Python that it finds. So if we run this again, and yet again, if we we'll print the line out. So if we run this, we say Python, Python, Python. Here we see it found and replaced Python, Python, Python with Ruby, 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 but it did not actually make the change because we did not use the exclamation point version. So we run that one more time, just to be sure. And lo and behold, this time it didn't find it, right? Because and the first one found it, right? So it says scripting language is mentioned, but we did not use the /i, so it was exactly matching. It did not use case insensitive. So one way we could fix that is we could say, well, we could use grouping, and we could say capital P or little p for Python, and that might fix that would at least fix the first one, the second one. So if we did that, we say we made a mistake when we typed the first time. Python, we did that. Well, it found the first one and fixed it with Ruby. It did not do the case insensitive, which is what we really want. So we can do that one more time. And Python, Python, and it found both fixed them and was global and did the substitution correctly. So that's the gist of regex. The next lecture on Ruby immediately following this is a full treatment of regular expressions, understanding all the different ways that we can use them, what we can use them for. So all these examples will be listed inside of on the GitHub, and in a new Git folder, a new Git repository called Ruby CSCI 305-Ruby-examples under the directory Ruby 1. All the examples for Ruby 2, Ruby 3 lectures, and the regex lecture will also be in there as well as I build them. So things will change. Be aware. No need to fork that repository. You can clone directly from it. Don't push. Anyway, have a good time, and I will talk to you in class, or you can hear my voice on the next lecture. I'm sure you all are excited for that. Thanks a lot.